Hello, today we're going to review some graphing of the 6 trig functions. So let's get started, beginning with this problem. Graph the following function over a 2-period interval. Give the period and the amplitude. Well, it looks like it's a cosine curve that we're graphing. So let's just remember something, that cosine x, if you're just looking at the graph of y equals cosine x, the period is 2 pi, and we say the amplitude is 1. It's bouncing between 1 and -1. Excuse me, my 0 here looks like a 2, doesn't it? And if you were going to just sort of stick the graph in there, it starts off at 1. There. And let me see, something like that. This is the graph of y equals cosine x. And let me just go ahead and graph y equals sine x over that same period from 0 to 2 pi. Sine is the one that looks more like an S, and cosine looks sort of like a C if you tilt your head. So here's sine x. And this is just a little snapshot, one period. They keep going and going and going forever. Both of these do. So on problem number, well, this first one we're doing y equals cosine 1/3 x. It says find the period of this function. To find the period, oops, this is y equals sine. To find the period for sine or cosine, you go 2 pi divided by the coefficient of x. The coefficient of x is this 1/3. So we have 2 pi divided by, oops, what's that wrong with me today? I'm forgetting to switch. So the period, to calculate the period of sine and cosine, it's 2 pi over the coefficient of x. Since that coefficient of x is a fraction, probably the easiest way to simplify this is just to multiply above and below on the main fraction by 3. If I multiplied above and below by 3, you'll see that here the 3's would cross cancel, and we no longer have a fraction. The period is just 6 pi. So let's type that in. 6 pi. 6. And there's the pi symbol. Check it. And now what does it say? Find the amplitude. Well, the amplitude is that maximum distance the graph gets from the horizontal axis. Like up here, maximum distance is 1. In general, amplitude is always positive. And so, if you had a graph like y equals a times either sine or cosine, x or something after that, the amplitude is defined to be the absolute value of x, whatever the function's being multiplied by. The absolute value of it. Amplitude's always positive because it's a distance. Looking at my function y equals cosine 1/3 x, there's not a number in front of cosine that the function is being multiplied by. So we assume that the amplitude is, or the number here is a 1, just like up here. It's sine x and cosine x. The amplitude is 1. So our amplitude is the absolute value of 1. I hope that doesn't look like 111. So I'm trying to make these bars in purple. And I'll make them a little bigger. So what number am I going to type in as the amplitude? 1. Now, sine and cosine are the only trig functions that have amplitude defined, right? Because the other 4, tangent, cotangent, secant, cosecant, they keep going and going and going. And now they want us to graph this. So we're going to graph y equals 1/3 x. Now realize these graphs just keep going and going. So we just need to graph enough of it so that we can figure out which graph it is, A, B, C, or D. In order to graph this, I'm going to first decide what period will be equivalent to 0 to 2 pi. What values of x will get this thing to make one loop around the unit circle? To do that, I just take the angle, and I call the angle whatever comes after the trig function. I'm going to set it between 0 and 2 pi, and isolate the x. I'll do that just by multiplying straight through by 3. So instead of 0 to 2 pi, I'm going to be graphing from 0 to 6 pi. Okay, 6 pi. I'm going to break this up. 3 pi would be right in the middle. And the amplitude is a 1. So let's, just to make the graph look a little nicer, I'm going to say right here, it's 1. Right here, -1. And I'm just going to take this shape and these 5 dots right here, I'm about to make them here. 1, 2, 3, 4, 5. So which graph, I know it's a multiple choice, looks the most like that, from 0 to 6 pi? At 3 pi, it should be down at the very bottom. So let's look. Oh gosh, now notice the way it keeps going and going. They've drawn it, they've drawn bigger graphs than ours. But here's what I'm going to suggest you do. Why don't we look at one particular part of the graph? Let's just look right here. At 0, it should be up at 1. 3 pi, it should be down at -1. At 0, it should be up at 1. No. Here, 0, it's at a negative. Okay. What about this one? Look at that. 0, it's up there. At 3 pi, we assume this is 3 pi because that's 6 pi. It's down at -1. I'm thinking it's B. Do y'all want to... Okay, it's definitely not C. Oh, I'm sorry, I forgot to turn off my phone. No, what's wrong with this one? It looks sort of like the correct shape, but you see that? here they have it going just from 0 to 2 pi over 3. No, no, no. Which one did we say it is? It is B. Once again, hopefully you saw how I did that. I just look at my graph. Okay, let's look right out here and here. Which one has this shape? Now they drew it more than just 0 to 6 pi. Looks like they went negative 6 pi to 6 pi. Oh, I just noticed. It says graph it over a 2-period interval. I just drew one. Now, let's see, here's another one. Y equals cosine 3x. Let me see. I wonder. Oh, okay. Problem 2. Y equals cosine 3x. It's the same instructions as the other ones. Find the period and amplitude and graph it. It might say graph it over 2 periods, but I just graph it over 1. Let's see. So the period and amplitude, this one's a little bit nicer than the first one because that coefficient of x is not a fraction. The period is 2 pi over the coefficient of x, 2 pi over 3. Let's go ahead and state the amplitude. Amplitude is the absolute value of the number that cosine is being multiplied by. Well, the cosine function is just being multiplied by 1. Absolute value of 1. It's still 1, so it's just like the one we just finished doing. Let me go ahead and punch those. You know what? Why not go ahead and graph it? And then I'll punch it in. Okay. 0 to 2 pi. Let's isolate the x. And that will tell us. No, I don't like that light on because it's going to make my shadow too obvious. So divide both sides by 3. Excuse me, divide straight through by 3. That tells us that it's going to make one of these shapes, instead of going from 0 to 2 pi, it's going to go from 0 to 2 pi over 3. So I'm going to draw a small graph. The amplitude is 1. Instead of 0 to 2 pi, is 0 to 2 pi over 3. I'll break it up into fourths. And then I'm just going to draw those same 5 key points like I did here. 1, 2, 3, 4, 5. Now some of y'all are punching these into your graphing calculator, and that's fine. I'm just trying to, I'll do it the old-fashioned way. Okay, so what did we say the period is? 2 pi over 3. And that amplitude is a 1. Now, if there were like a 5 or a 6 in front of that COS there, that would be multiplied by some number other than 1, then that would be amplitude. Maybe we'll see one like that before it's all over. Now, I'm going to blow these up, keeping in mind that it's going to go from, it's going to make that little cycle, or that little, from 0 to 2 pi over 3. It's going to look like that. So let me see. Which one is it? I'll start blowing up. It's not this one. This is going 0 to 6 pi. This one's going 0 to 2 pi over 3, but it should have started up here, not down here. It looks like on this one it was multiplied by -1, the way it was flipped across the x-axis. Remember, multiplying by a negative flips it across the x-axis. So again, it's not this one. Besides the fact that it looks like it has a period of 6 pi, it's being multiplied across the x-axis. It won't be this one, is it? Does this look like what I drew? Yeah, 0 to 2 pi over 3, starting up here in the y-axis at 1. So, D. Oh, good. Sine, I was about to say, I hope we get some that have sine in it. Determine the amplitude, period, any vertical translation, and any phase shift. Phase shift is what we call the horizontal shifts. Okay? So let me write this problem down, and we'll do the amplitude and period first. Okay? So just doing a little review. Y equals -4 sine. Now what comes after the trig function, that's what I call the angle, or immediately after the trig function, sine x minus pi over 2. Well, the amplitude is the absolute value of the number that the trig function is being multiplied by. Sine is being multiplied by -4, so the absolute value of -4, that's a +4. Amplitude is always positive because it's a distance. The distance from O. Oh gosh, look at that. I'm just talking and talking. I'm sorry. Let me go back over. I was writing and y'all couldn't see what I was writing. Amplitude is the absolute value of the number that the trig function is being multiplied by. Over here on the first two, it was just being multiplied by 1. Here, however, trig function's being multiplied by a -4. The absolute value of -4 is 4. Let me punch that in. 4. Now the period is 2 pi divided by the coefficient of x. Let me write that down. Period is equal to 2 pi divided by the coefficient of x. The coefficient of x is the number that the x is being multiplied by. And the number that the x is being multiplied by is just a 1. So what's that going to give us as a period? 2 pi over 1 is just 2 pi. So 0 to 2 pi. It'll make one of those cycles over the period from 0 to 2 pi. Now, for a vertical translation, that's up and down. In order to have a vertical translation, there needs to be a number either added to this function or subtracted. It could be written either like right here at the end, like if it is a +7, then, okay, or it might be in the front, okay, +7 minus. Up or down is what's added. There's no vertical translation here. No vertical translation. Okay. And now the phase shift. The phase shift is the horizontal translation. Phase shift. To get the phase shift, what I like to do is just take the angle, and the angle is whatever comes after the trig function, set it equal to 0, and solve for x. So to calculate the phase shift, I'm going to set x minus pi over 2 to 0. And that's not too difficult to isolate the x. What would I do to solve for x? I would need to move the pi over 2 over. Just like a vertical translation, you have to say up or down, depending on whether it's a positive or negative number. We didn't have one this time. With phase shift, you need to say right or left, depending on whether it's a positive or negative number. Instead of starting at 0, you're starting at, the primary cycle is starting at pi over 2. So let's see, how do they word this? The phase shift is, oh, well, heck, I thought we were going to have to say to the right, but they've already said it. That's telling us that the phase shift, that number, there better be a positive number. We had wound up with a negative number when it's clearly to the right. That means we messed up, doesn't it? Oh, and here's another one. Same type of instructions, amplitude, period, vertical translation, and phase shift. So let me write this down. Number 4. I just love to use red ink and every color possible. But I'm trying to get away from that because so many people have trouble seeing colors. But I have to confess, the color I have a lot hard time seeing is blue. X minus 1/5. Let me make sure I didn't miscopy it. The other day I miscopied a problem and it was a long one and I'd done 15 minutes. 15 minutes on it before finally realizing I miscopied it. And so on that day, the students didn't get out early from class because I had to redo the problem. I thought that was funny. They didn't, but okay. So first of all, we're told to find the amplitude. Amplitude is the absolute value of the number that the trig function is being multiplied by. So in this case, amplitude is 3. These are absolute value bars, not 131. Then, let's calculate the period. The period is 2 pi over the coefficient of x, and it might be tempting to say 2 pi over 1, but be careful. This pi over 4 here, doesn't it really mean that both of these are being multiplied by pi over 4? So the coefficient of x really isn't a 1, is it? What is it? It is a pi over 4. So now let's simplify this. I think what I'm going to do to simplify it, this main fraction bar here, I'm going to multiply above and below by 4 because then that gets rid of the compound fraction. We no longer have this 4 down here. Up on top, we have an 8 pi. And on the bottom, what do we have? Just a pi? So we're not done here. We can cancel the pi's. So the period here is just 8. So we've done the amplitude, the period. Let's see. Vertical translation. Is there some number that all of this function's that's being added or subtracted? Added to or subtracted from here? No. Okay? So, once again, no vertical translation. I like this graphic analysis problems. And finally, we need to do the phase shift. To do the phase shift, you take the angle and set it equal to 0. Angle is all of that. So I'm now doing the phase shift. Pi over 4 times x minus 1/5 equals 0. Sometimes students say, well, distribute the pi over 4. I don't really think that's the best way to go about it. If we're trying to isolate the x, why don't we multiply both sides by 4 over pi? Why would we do that? Well, oops. I have a pen that erases. There. Well, by doing that, aren't the 4 and the pi's gone? All we have is x minus 1/5 equals 0. Isolate the x. And what's this phase shift going to be? Will it be to the right or to the left? I'm thinking it's going to be to the right. Now, let's type in these answers. Oh, yes. There. What are we going to type in for amplitude? The amplitude is 3. The period looks sort of strange because there's no pi in it, isn't it? 8. There's no vertical translation. And what do we, okay, it says to the right, so 1/5. So instead of starting its little basic shape of 0, it starts at 1/5. Okay. We haven't done any tangent or cotangent yet. So let me just sort of review these basic shapes. Y equals tangent x has a basic shape that looks like this. It has vertical asymptotes. I'm going to have to use some color here to try to distinguish at negative pi over 2 and positive pi over 2. And then it just keeps going and going forever. And the shape looks sort of like that. It's going up from left to right. Let me go ahead and write the graph cotangents so you can see that one. The basic shape. Y equals cotangent x it makes one little cycle from 0 to pi. You'll notice the period for tangent and cotangent is just pi units. After pi units, it starts repeating again. Oh, my cat I'm doing this at home on a Saturday morning, and my cat is curious. Let me try to get him off without destroying the camera. There. There. See. I'm a sucker. I got that cat because a friend of a friend had a cat in Denton, had that cat in Denton, and then was going to move home and not bring the cat, and she was going to dump the cat at a apartment complex. I remember saying, "You can't dump that cat. You've had it as you raised it. It was a little kitten." And she said, "Well, if you don't want me to dump it, you take it," and I'm a sucker. What could I do? So, anyway, notice when you look from left to right, tangent x's basic shape, it goes up when you look from left to right. Cotangent, when you look from left to right, it goes down. If you're trying to memorize these, and the more stuff you have stored up here, the less you have to write on a sheet of paper and stuff. So, cotangent goes down when you look from left to right. Y'all see where I'm going with this? How do you remember which one goes where? Well, after T in the alphabet is what letter? U. After C, D, cotangent goes down, tangent goes up. It, uh, should be obvious, or it might be obvious to you. How will you remember which one is 0 to pi, and which one is the negative pi over 2 to pi over 2? Well, which one of these has what looks like a 0 in it? Cotangent? Yeah, that's what I tell students how to remember this. But have I actually done the problem yet? No. Let me get on over here. We're graphing y equals -3. So this is problem number, is it number 5? Yeah. Y equals -3 times tangent 1/3 x. Okay. Well, first of all, I should mention something that I've already mentioned one, but I want to mention it again. If a trig function is being multiplied by a negative, that just flips the graph across the x-axis. So this is positive tangent x. If I wanted to look at the graph of negative tangent x, it would look like that. Y equals negative tangent x. I'm deliberately using a light color here. Flipping cotangent across the x-axis, that would give us negative cotangent x. Remember years ago, this really good student said, wait, so negative tangent x is the same as cotangent x. And I said, yes, except for what? The asymptotes. Okay? It doesn't change the asymptotes. Negative cotangent x goes up like tangent when you look from left to right, but it still has the 0 to pi asymptote. We talk about amplitude only for sine and cosine. Amplitude is the furthest distance the graph gets from the x-axis. See, these things keep going and going. So if we're going to put something, we'd say, I guess we could say the amplitude is what, infinity? No, we just say there's no amplitude. So we know it's going to have a basic shape like this orange curve because of the negative. Midway through, here and here, it's at whatever this number is. So midway through here, it's going to be at 3. Well, depending on what you're using. -3. But the main thing is it's going to have this orange shape here. Now let's figure out the asymptotes. To find the two asymptotes, you're going to take the angle and set it between -pi/2 and pi/2. Sometimes you'll see people, books or people just making two separate equations. 1/3 x equals -pi/2. 1/3 x equals pi/2. I like doing it all in one big step. To isolate the x, I need to get rid of this 1/3. So what would I do? I would need to multiply through by 3. So we have -pi/2 times 3. I'm going to write that as -3pi/2. And then 3pi/2. So it's going to look like this orange curve, but the asymptotes are going to be at -3pi/2 and +3pi. So negative, oops, -3pi/2, +3pi/2. There's my vertical asymptote, and it's going to go like that. But what I was trying to show earlier is midway through, it'll be at 3 and -3. So if I go 1, 2, 3, it's going to be 1, 2, 3. And now just try to make a curve like that little orange one there. It runs like this. Oh gosh. I know your little graphing calculators will make a much prettier graph than what I have here. Okay, so 3. Well, heck, all of these have the 3pi/2 asymptotes. We can certainly knock out this one. It's not C, and it's not B either. Do y'all see the 3 dots there? If you look at my 3 dots, 1, 2, 3, it's not there. It's got to be this one. Is this what it looks like? And they have it scaled. Oh, wait. I should blow this up. I'm sorry. They have it scaled 0 to 10. So you have to count 1, 2, 3. There. 1, 2, -3. There. So this one is A. Okay. Oh, here's one. For cotangent. Y equals 2 cotangent 5x. Y 2 cotangent 5x. Oh, I always wonder on this one, the way there were only 3 choices, do you think the person who was writing this problem, the programmer, took a lunch break and forgot, oh yeah, you still had one more choice to make D, or maybe it was a Friday. Oh, 5 o'clock, quitting time. I'll pick up here on Monday, and by Monday he forgot. He went on to the next one. Hey, oh wait, what happened? Oh yeah, I'm doing the teacher thing, so it'll be changing the numbers, and I shouldn't have gone back to the other one for some reason. Uh, and they've already changed it to y equals 2 cotangent 3x. Oh, so this, I won't go back since I'm on the, y'all's doesn't do that. If you leave a problem when you're on the student side, you see mine changed from a 5 to a 3. I should know better than that. Okay, so y equals 2 cotangent 3x. Since cotangent is being multiplied by a positive number, it's going to have this basic shape here, okay, going down. If it had been multiplied by negative, it'd look like the orange curve. So let's see. Instead of 0 and pi, let's find those asymptotes. Take the angle 3x, set it between 0 and pi, and isolate the x. So 0, ooh, I'm sorry, I'm too low here. Let me lift up this. So instead of 0 and pi, 0 to pi over 3, let me draw. So doing this the old-fashioned way. So the asymptotes are at 0 and pi over 3. We're going to put our 3 primary dots. It would be up here 2, -2. Cotangent is the one that goes down when you look from left to right. Let me draw my little dots there, there, there. And now let's see. Down. I didn't get the curvature good there, but okay. It's got to have it good enough to choose which one it is. It is, oh, this says pi over 6, way over here. Is that what that is? Pi over 6? And so, well, besides the fact that it's going the wrong way, it should be 0 and pi over 3. Unless I miscopied the problem. See, what about this one? Is that it? 0 to pi over 3. Oh, pi over 6. They're labeling the number right in the middle. Okay. Half of pi over 3 would be pi over 6. And does it look like it's down at a 2? Well, what about? It's definitely not C. Definitely not D, because the asymptotes aren't at negative pi over 6 and positive pi over 6. The one that's closest to it, B. When I say closest to it, I should be ashamed of myself. It's actually a very good graph. They get that curvature right. And now we're going to graph secant and cosecant. Let's see. just review for y'all how to graph secant and cosecant with secant x secant is the reciprocal of cosine. So I'm going to just real quickly sketch cosine. Cosine starts up at 1. It looks like that. Can y'all imagine cosine? I like to connect the dots, but some students prefer just to show the points, and that's fine. Asymptotes, we're now taking reciprocals of all of these numbers. This number right here is a 1. The reciprocal of 1 is 1. The reciprocal of 0 is undefined. Oh, I thought I had black. And to show the undefined, we're using vertical asymptotes. The reciprocal of -1 is -1. And then you take the reciprocal curves, which look like this. Basically, what you're saying is the reciprocal of 1 is 1. Then you're looking at the numbers between the y values between 0 and 1, like a half. The reciprocal of a half is 2. The reciprocal of 1 over 10 is 10. Up it goes, just like that. Now we'll do the exact same thing to draw cosecant x, except cosecant is the reciprocal of sine x. So I'm drawing the graph of y equals sine x, 0 to 2 pi. Sine x is the one that looks at like more like an S. 1, 2, 3, 4, 5. Yeah. Now do what I did over there. Draw the asymptotes. The asymptotes of where the graph crosses that x-axis. The reason you have asymptotes there is you're saying the reciprocal of 0 is undefined. Like right here, this is a y value of 0. Reciprocal is undefined. Reciprocal of 0 is undefined. Notice I'm taking the reciprocals of the y values. I'm not taking the reciprocal of the x values. I'm not saying the reciprocal of 2 pi is 0. I'm saying the reciprocal of 2 pi would be 1 over 2 pi. And now, here we go. It's going to look like two U-shaped figures. Now, the key to these is to get the reciprocal curve drawn correctly. If it's secant, draw cosine. If it's cosine, draw secant. So, this is number 7. Y equals -2 secant 1/4 x. The first thing we've got to do is draw y equals -2 cosine 1/4 x. Okay? It's secant. It's going to look something like this, except my orange graph is going to be flipped across the x-axis. This is y equals positive cosine x. Multiplying by a negative reflects it across the x-axis. And so, let me see. Let's do the amplitude. Amplitude is the absolute value of -2. So instead of bouncing between 1 and -1, it's going to be bouncing between 2 and -2. Instead of going from 0 to 2 pi, my logic is, what value of x will make this angle go from 0 to 2 pi? Well, I'm just setting it. Oh, sorry about that. I'm first drawing y equals -2 cosine 1/4 x. Absolute value of -2 is a +2. This graph is going to look like this. Okay. How would I solve that for x? Just multiply right through by 4. That'll hit the x by itself, won't it? So we have 0, 4 times 0, x, 8 pi. Ooh, wee. Zero to 8 pi. Instead of it bouncing between 1 and -1, it's going to be between 2 and -2. But it was multiplied by negative, which means we're going to have to multiply by negative. It looks like this. So let me sketch that in. It's going to start here. 1, 2, 3, 4, 5. So it looks something like that. This is just the graph of -2 cosine 1/4 x. So let's just draw my asymptotes. Since this is 8 pi, if we want to put more numbers in here, this would have to be 4 pi. And what about right there? 2 pi and 6 pi? Now, get my black ink. I'm going to draw the little reciprocal curves. They look like this. Here. So I'm going to have a little bit of a remnant left over. Here. And I have it from 0 to 8 pi. But there's nothing that says it has to be drawn like that because the way it just keeps going and going. Can y'all picture this thing just keep going and going? So let's look at the answer choices. We can definitely say it's not B, and it's not D. So, let's see. How about looking between 2 pi and 6 pi? Look at my graph. It says between 2 pi and 6 pi, we should have that little U-shaped curve there. Which one of those has it? Right here. Oh, let's see. That's 6 pi. It's definitely not this one, right? Between 2 pi and 6 pi, it should be going up. Let's see. I think this is the one. Okay? There's the asymptote at 2 pi. Notice how it's going up. Got 6 pi, 4 pi, 2 pi, 0. Notice Another way you can decide on which one is, look at this. Which one, if you look at the y-axis, which one is doing this at the y-axis? Crossing there, and you can tell it's going to keep going. It's going to make the little upside down U there. Yeah. Okay, there's the y-axis. It's at -2. How do I know it's at -2? Well, it says -10 there. Okay. So C it is. What do we have now? Okay, good. A cosecant function. 7, 8. To graph this cosecant curve, we're going to first have to graph what's the reciprocal of cosecant? Sine? Y equals cosecant x minus 3 pi over 4. This is another one with just 3 choices, but it doesn't have like a cotangent or tangent curve. There's not one you can just glance at and immediately discard. So I'm graphing y equals cosecant x minus pi over 4. And first thing we're going to graph is y. Oops, I meant to get my bluing. Y equals sine x minus pi over 4. Well, the amplitude here is a 1. So it's going to be bouncing between 1 and -1. Now, where will the fundamental period start and stop? If you take the angle and set it between 0 and 2 pi, you're asking yourself, what values of x will make this go all the way around the unit circle? Well, let's add pi over 4 straight through. That'll get the x by itself. So we have 0 plus pi over 4. That's pi over 4 less than x less than, oh, let's see, how are y'all adding fractions? 2 pi plus pi over 4. I would think of this 2 pi as 4 pi over 4 plus 1 pi over 4. Is that going to be 5 pi over 4? So, 0. Okay, so pi over 4, 1/4, 2/4, 3/4. Right out of there. 5 pi over 4. So 1/4, 2/4, 3/4, 4/4, 5/4. It's bouncing between 1 and -1. That was the amplitude. And sine x has amplitude. Cosecant x doesn't. And I'm just going to draw my 5 cosine points. Excuse me, sine points. 1, 2, 3. This starts on the horizontal axis. So 1, 2, 3, 4, 5. There's sine. There should be there's a vertical asymptote at pi over 4, at 3 pi over 4, and at 5 pi over 4. And here's the little U-shaped curves. I don't know why system put in the little arrows. It just makes it look even messier, doesn't it? So let's now start looking at the answer choices. One thing we can do is look and see which correct answer choice has a asymptote at pi over 4, and then it's going up. And this would be 3 pi over 4. Let's see. Here's the first one. No, there's not an asymptote at pi over 4. It's not A. Now, this one looks promising, doesn't it? Pi over 4? Oh, but no. There's an asymptote at 5 pi over 4. But what's wrong? Shouldn't there be an asymptote at 3 pi over 4 also? See here, they just have one big U between pi over 4 and 5 pi over 4. That's not what we have. Between pi over 4 and 5 pi over 4, we should have one going up and down. It's not just one big U. So it's not B. It better be C. Let's see if I blow it up. Well, this one doesn't. Oh, well, let me look back at it. A, B, C. Which one is asymptote? Is it B? Let me look. Pi over 4 to 5 pi over 4. I better check at this point and see, have I miscopied the problem? Oh, wow, y'all, I'm sorry. This says cosecant x minus 3 pi over 4. Did it change those numbers again? Or did I just miscopy it? Okay, well, that's fine. We will have another of this. I'm just going to do another one, okay? So you get to see another example. Y equals cosecant x minus 3 pi over 4. And y'all are doing these on the student side of things. It isn't changing the numbers like that. But here, for some reason, it keeps changing my numbers. Not for some reason. It's thinking that the teacher wants you to do another example. So let's go back through it. We're still graphing sine x minus 3 pi over 4. So the amplitude for sine is still 1. Setting x minus 3 pi over 4 between 0 and 2 pi. I would add 3 pi over 4 all the way through. So 0 plus 3 pi over 4, that's 3 pi over 4. Now 2 pi, 4 pi over 2 plus 3 pi, over 4. 8 pi. Oh my goodness. Y'all see what I did wrong. I can't even add up here. 2 pi would be 8 pi over 4 plus 1 pi over 4. This would be 9 pi over 4. My goodness. I can't even add fractions today. Okay. But that's still... Oh, it changed when I got it wrong. That was my mistake. I'm sorry about that. 2 pi, 4 is 8 pi over 4 plus 1 pi over 4. I think I went 4 pi over 2, didn't I? Well, okay. As long as I don't mess up this time, okay? 2 pi is 8 pi over 4 plus 3 pi over 4. That's 11 pi over 4. Let me see. 0. Oops. 3 pi over 4. Right up here, 11 pi over 4. So this would be 3 pi, 5, 7, 9, 11 pi, and, oops, 1 and negative 1. 1, 2, 3, 4, 5. That's what I messed up on. I messed up on my adding fractions right there. Can y'all believe that? Well, y'all can probably believe it. I can't. Now, asymptote, asymptote. Uh-oh, I was going to do that in black. 1, 2. Oh gosh, let me see. So we have asymptotes at 3 pi over 4, 3, 5, 7, 9. So this is 7 pi over 4. So let's see. Between 3 pi and 7 pi over 4, we should have the little U shape going up. Between 3 pi over 4, no. Between 3 pi over 4 and 7 pi over 4, no. Between 3 pi over 4 and 7 pi over 4, it's going up. I'm looking at this region right there. Okay. Okay. And I think we'll take a little break right now. I need to rest my mind, but I'll take a little break, and then we'll do some more problems. So thanks for watching. Let me stop recording.